Students. So today is the first day of your third semester of MSc Physics. You have already completed your first year in MSc, and during last semester we studied classical electrodynamics, which was a combination of uh, electromagnetics, plasma physics, and of course relativistic electrodynamics. And it was very interesting to know about that subject, but because I also had to study some of the critical topics which were not I will not say new to me, but I had studied some long back, like your Cherenkov radiation was something new to me. So I enjoyed refreshing it. So now today we are going to start this course, fiber optics and lasers. And I have not yet supplied you the syllabus, which I expect that it will be supplied by today afternoon. But I understand what would be in the syllabus, and so I have just identified three or four major uh, say components of this course, which we might be discussing. And even if there is a change in the syllabus, I am quite sure that whatever I am going to discuss today will be the major component of your syllabus. So that as far as the syllabus is concerned, I'm quite sure. So let's start today. And since this is the first day of our topic, I would like to discuss more about the course, what it is, its scope, what we will be going to discuss in the syllabus, and what are the expected outcomes. That means after completion of the complete course, that means by the end of um, I think 50 lectures or 50 sessions, uh, I expect that you should be in a position to develop a better understanding, and not only better understanding, because you are in MSc, you should be able to um, think of designing a system, at least at the broad level, understand the intricacies of different components of the system, and maybe at the during the last phase of this course, you should be able to think of an idea, think of a project, uh, which you which you might uh, plan to develop, or at least to investigate. So this is my idea about um, today's lecture. So let's start with the introduction first. So I'm going to the next slide, please. So see, see the topic name was, the course name is Fiber Optics and Lasers. So let us first discuss the fiber optics. I'm sure I don't know whether you have studied fiber optics in your. I'm sure you might have studied the basic part of that. So assuming that you have studied the basic part of it, I will just touch it briefly, and I will focus more on the applications part. As you can see here in the diagram, this is the diagram of an optical fiber, and it's an optical device which works on the principle of total internal reflection. Total internal reflection. I think you might have read about the Snell's law in your BSc, and even I think in your 12th class also you might have studied. So, and you might have also studied during refraction that beyond a particular critical angle, the incident ray, when it enters the surface of another medium which has a refractive index slightly lower than the previous medium, then the incident ray will tend to revert back to the denser medium. So the situation is similar like a reflection, but this is not really a reflection in that sense, because it is happening because this incident ray is falling on a surface of a material which has a refractive index which is lower than the refractive index of this material, right? So this particular case is considered as the total internal reflection, and since total internal reflection is occurring at a particular critical angle, at some other angle, let's say if the incident ray goes like this, then it will go through the second medium, of course, moving away from the normal, right? And as you start increasing the critical angle, that theta c, so a point will come where it will keep on moving from the normal and keep on moving, and finally it will enter into the same medium itself. The advantage of this total internal reflection is that whatever optical beam is allowed to pass through, because through these conditions of critical angle, this optical beam will go into the surface, and since the angle of reflection is angle of incidence is equal to the angle of reflection in any in a reflection law, so here also the beam will enter at the degree of angle of reflection and so on. So finally what will happen, that because the optical beam entered here at a particular angle, it will continue to get reflected through the total internal reflection process along the length of this optical fiber, provided the refractive index of this medium outer, the white one which you see, is always lower by the same amount which it was here, right? So that what is happening, that if you maintain the refractive index of this medium and this medium along the length of the optical fiber, the total internal reflection will continue to occur. And since it continues to occur, that means if you have a signal into that optical fiber, then that signal will continue to travel till the end of the optical fiber. So that is how a communication process occurs also. So I hope I have covered the basic part of the optical fiber, and the applications which I thought to discuss more is that, of course, optical fiber you can use for communication purposes, yes, and you just saw the example. In fact, today when you see the communication which you are having through your broadband network, the connection which comes to your house from the transmitting system or relaying system is through underground optical fiber cable. It's unlike your mobile communication, because in mobile communication it is uh, through the transmitter or relay system at the rooftop, and which comes to you through the electromagnetic radiation process. But in the optical fiber communication, it comes through the optical fiber. So these are the two different modes of transmission. In the optical fiber, it is a guided transmission, whereas in the upper atmosphere, in the electromagnetic radiation, in the open air, it is through the omnidirectional radiation process. So So anyway, these two are different things. So we are talking here about the communication. So you can say that in optical fiber, your communication is a guided communication. That means the optical fiber is more like a guide, right? So because it directs your optical beam to go in a particular direction. So you will learn about the optical waveguides also during the course of this discussion later on. So one major application is the optical communication, and since it is optical communication, that means on one end of the optical fiber you will have a transmitter, and on the other end of the optical fiber you will have the receiver, and the transmitter will be something like a optical source because it has to launch optical beam, right? So this is how communication system will work. Now the second application which I mentioned was diagnostics. By diagnostics I mean here that you are going to uh, use an optical fiber for diagnostic purposes. Let's say for example, uh, one thing I forgot to mention, that the dimensions of these optical fibers are in the range of micrometers or millimeters, some 100 micrometer, some tens of micrometers, or even millimeter, or even 1, 2, 3, 4, 5 millimeter also. You might have seen some of these optical fibers uh, in your neighborhood. So these optical fibers, since they work as a channel for transmission of optical beam, that means you can use this optical fiber as some sort of a torch or as a illuminating system. So for example, if you have an optical source here, a laser beam is here, then the sorry, then the laser beam will pass through the optical fiber, and at the end it will illuminate the object where you are putting your optical fiber. So it can be used as a illuminator, or you can say that if you are uh, going into dark, and there is a very narrow space and you want to look from a different position, then you can allow the optical fiber to move into that dark tunnel, and if there is a camera which is locating the movement of the optical fiber, so wherever the illumination is there, you will be able to see the details of that illuminated part through the camera system, which is put at the beginning of the optical fiber. So like in a body, the doctors do this optical diagnostics through optical fiber. uh, they put a camera system, the illuminator, and it goes through many of your internal body system, and give a picture or a idea about what is happening to the doctor. So that means these diagnostics can be part of a medical system. These diagnostics can also be part of a physical inspection system. Let's say in a sewage tunnel, it is difficult for a person to go inside because it is hazardous. So you can put an optical fiber into that, and at the top of the tunnel system, you can sit there with your computer, and the CCTV camera is guiding you, and it is taking the optical cable to wherever you want into the tunnel, and you can see the picture on your computer. So diagnostics is both for physical inspection as well as for medical inspection, medical diagnostics, and also if you can connect it through a microscope, then the microscope imaging can also take place. That means if the optical fiber is of a very small diameter, right, and then the lens system is mounted on the in the optical fiber itself, then you will be able to see even the micrometer level objects also. So the diagnostics can be at three levels. One is at the physical level, macro level investigation in a body for medical inspection, medical diagnostics, and for microscopic investigation also. Then the third application area is research, which I can just uh, uh, extrapolate from what we discussed just now on diagnostics part. So it can be used for research purposes also. So these are the major application areas, and you will come across these applications when we go into the subject in detail. Then, as far as lasers is concerned, you all know about the abbreviation of lasers, light amplification of stimulated emission of radiation. Uh, I'm sure you know about the difference between monochromatic uh, radiation, then directional radiation, coherent radiation. Laser is a coherent radiation. Uh, uh, you can understand the difference between the two, and this picture shows how uh, ordinary light differs from a laser light. See, it is a monochromatic, but whereas ordinary light is not monochromatic. That means you have polychromatic light source, multichromatic light source, right? Lot of uh, wavelengths are there, right? Here the wavelength is single or very narrow bandwidth, and then it is here the laser light is directional, here it is omnidirectional. That means the energy is distributed along all directions, so that you will not get the intensity part. As far as the coherency is concerned, the laser light is coherent. That means two uh, two waves will have no phase difference or a fixed phase difference, whereas in an ordinary light the two waves will have variable phase difference, and they will interfere with each other, cause constructive and destructive interference, which you might have studied in optics in your BSc or even in 12th class. So I will not go into the detail of uh, these definitions. We'll go through these details whenever the actual topics comes. Here the idea was to tell you that during this course you will be studying about different type of lasers, like there is a gas laser, solid state lasers, liquid lasers, and when I say atomic laser, then atomic laser can be in the gas laser or in the liquid laser. Similarly, molecular lasers, it can be in the liquid laser, it can be in the gas laser also, right? So there are different types of lasers, and each have different characteristics in terms of output power, then directivity, efficiency, right? So these are the things which we'll be discussing. Applications part, there are many applications of laser. Now laser is covering almost entire area of applications, whether it is science, whether it is engineering, whether it is day to day, even layman working area, even in a shop. When you when you scan a barcode, you use your laser. So communication, surgery, you saw the applications in optical fiber. Welding, that means you can melt a material, join them. Material and surface modification. Metrology, that means measurements. Diagnostics, which I just discussed. Research. So these are the application areas of lasers. And now when I combine the fiber optics and laser, because I just wanted to first discuss about the fiber optics to make it simpler, then lasers to make it simpler and singular, and then I have combined here. And see, you can see here that this is how a fiber optic laser system looks like, because you have a optical fiber inside, and then it launches the optical laser system from this. There can be a optical fiber system where the complete roll of optical fibers are there, and laser comes out through. you can have a 2 kilometer of optical fiber in a circle, bent in a circle, and at the end of the optical fiber you will get a laser beam. That means even if you are bending the optical fiber, the laser beam will also travel accordingly, and finally you will get the laser output. So the advantage of such a fiber optic based laser system is that you can manipulate the optical fiber to change the directions of your working, and the application areas are same: communication, surgery, welding, materials, surface modification, metrology, diagnostics, and research. Now, so I have tried to introduce you to the subject which we are discussing. Now let's see what you will be able to do when you complete the course. And I am putting it here so that from today onwards, when you start studying this subject, you will be focusing on these aspects, and you you may be demanding from me that you are not that what about this appreciation part? Are we able to appreciate the communication systems based upon fiber optics? Are we able to appreciate the details of its components? And if through this course I am not able to help you on appreciation of these systems, that means either I have missed something or you have missed something. So this will remind you and me both that we have to cover this part. Then after the completion of this course, you should be able to demonstrate the working of a fiber optics laser. That means if somebody in a research organization asks you how an optical fiber works, you should be able to answer. Or in your exam, or even if a layman wants to know that how a fiber optic works, you should be able to explain to him. Then the design concepts. That means you should be able to understand the intricacies of a design of such a system. So that will help you in appreciating the details of a fiber optics laser system. Then you should be able to go into the details of the applications, like we discussed the medical surgery or the welding or material modification, at least how these systems work. And you will also be able to relate it with other topics which you might have studied during your BSc or even your earlier MSc classes. Say for example, when we are talking about the welding, that means melting a material. When we are talking about melting a material, that means we are talking about 3 4 things. One is laser, high power laser, energy, calorie is there already, heat input is already there. Now a material is there, that means material's specific heat is there. Now this is able to melt it or not melt it. That will depend upon how much heat is transferred, and how much after transfer, how much temperature is able to rise, right? How much power loss is there? So all these material understanding will also uh, take place in your understanding part. So these are the understanding of the applications and the details. And finally, I would expect that you develop a project idea from whatever you have studied. And I would say that from the once we cover the 50% part, one of you should remind me to so that we can start discussing about the project ideas. We will be completing the uh, course, but in parallel we'll be discussing about a project idea on any of the topics. And if you if you can afford, you can buy some components. These are available into the open market, and assemble it and see how it works, or you can make a report on that, or you can give a presentation. So that is how it will work. So I hope I have been able to uh, brief you about what we are going to discuss from here onwards in this system. If you have any question, you can always ask. So thank you very much. So let's see how our next 40 to 45 to 50 or 55 lectures